And it's looking a little bit fatter, so it is getting compressed. So that's what the 2/9 is going to do, is it's going to compress your graph. Pause your video. Try the next 3 yourself. All right, on problems number 24 and 26, it says describe the effect of changing a on the graph of ax squared. So kind of the same thing, it's just asked a little differently. Okay, so I have the original guy graphed, and then I'm going to come in here and graph my new graph 5x squared. So there's my original one. And my new one, if you could see, it didn't move left, right, up, or down, but it did get skinnier. So that is going to stretch, which makes sense because if you have a number in the front, that's going to stretch or compress. If you don't have a number, it will not stretch or compress. All right, so I'm going to graph this one. There's my original. And it got fatter, which once again makes sense because of the number. So that's going to compress. And then the last one, I'm going to type negative x squared. So all that happened on this one is it flipped, which means it reflected. So if you notice, there is no number in front of the x squared. If you don't have a number, you're not stretching or compressing. All right, so pause your video, try your next 3. All right, on 27 through 34, it says graph g of x on the same grid as f of x. So once again, utilize your calculator. I'm going to type 2x squared. There's my original. And there's my new one. If you want to get specific points, go to the table. All right, and remember, we're graphing the red one, so I'm paying attention to the red points. All right, so I got 1, 2, 1, 2, 3, 4. Oh, wait, no. Not 4, 8. 5, 6, 7, 8. All right, so my graph is looking something like this. All right, kind of ugly, but you can kind of see. All right, that's getting a little bit skinnier. It says describe the transformation. So when it gets skinny, S is stretch. So skinny stretch. All right, you're vertically stretching it out. It says, did the location of the y-intercept change as the result to the transformation? No, it did not, because you didn't move up and down. Didn't move up or down. So the only thing that's going to change the y-intercept is if your graph is going to move up or down. All right, so now I'm going to graph this one. Negative x minus 3 squared minus 4. There's my original. All right, there's my new one. So this one did a couple things. Remember, if you want to change so you get the dots or the lines, second format and go to grid dot. And then you get all the dots, which I know looks a little crazy, but it makes it a little bit easier to count. So you can see that this one moved right 1, 2, 3 and down 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Which also makes sense because if you look at your equation, this guy here is going to move right 3 because it's on the inside. It's your x. Oops, let me zoom out. All right, so this guy moves right. And this guy is going to move down. And we are facing downward because of this guy, which is going to reflect. All right, so we're also going to reflect. So on this one, it says, did the location of the y-intercept change as a result to the transformation? So if I go to my table, the y-intercept on this one is now at negative 13. So your y-intercept is at negative 13. And yes, it changed. So instead of at 0, 0, it's at negative 13. There's chicken in the fridge if you want it. Pause the video. Try your problems that were just like mine. Okay, we're almost done. Moving on to 16 and 18. It says the height above the ground of an object launched upward from a platform after X seconds